Okay, so hello everyone, this is Ubaid Rahman. I would like to welcome Dr. Muhammad Shirazul Islam, Director of Center for Infrastructure and Research and Services. He is also a professor of Department of Civil Engineering and Environmental Engineering from North-South University. It's also an honor to announce that SuperMap has been collaborated with North-South University, which can be confirmed as the foundation of education collaboration in Bangladesh. He will share some insights on his behalf regarding SuperMap and GIS industry. So, Professor Dr. Shirazul Islam, sir, you are welcome.
Okay. Thank you so much. Welcome participants to the SuperMap mini classroom webinar, volume 18. The title is GIS-based network analysis for the road network in SuperMap iDesktop. The webinar is arranged in collaboration with the Center for Infrastructure Research and Services, North-South University, along with the service provider or the software provider, SuperMap. CIRS is an institute under North-South University, which actually concentrate on issues related to infrastructure development. And obviously, for infrastructure-related projects, studies, and research, we frequently or very extensively use geospatial softwares. Obviously, there are some good software in the market for a long time. I don't want to mention the name, you may know. But at the same time, there are ample scope for new software to come, specifically with the specialized facilities or extensions and for specific purposes. What I could understand that the SuperMap people contacted and collaborated with us that they have software which can meet some specialized requirement like road network, water channel identification, building information like this. So these are obviously some very useful information for infrastructure related studies. At the same time, people from geography, geology, environmental science, environmental engineering, these people may find it useful as well. I mean, with the advent of modern technology, especially advancement in computer science, the visualization techniques, the visualization software, these are getting more and more popular because it helps researcher to conduct a study if they can visualize it in a bit better way or can get help from some software like this. So I hope all the participants, either from North-South University or elsewhere in the world, those who are participating, can be benefited from this particular webinar. The webinar will be conducted by an expert from SuperMap. So please do concentrate because it is always an advantage to have knowledge on any geospatial software if you are in a business of civil engineering, urban planner, architecture, or in this profession. So take this opportunity, and because there is an added advantage here, they will provide you free license and a certificate too, and that is very important as well. Many of you might be interested for that certificate, but simply certificate is not enough. I would rather request you to concentrate on what the lecture is and try to understand at least a glimpse of the software and the facilities that they are explaining today. So I hope all of you will enjoy it and make the maximum benefit from this training. Thank you again, SuperMap Authority, and thank you, participants, for attending the training. Thank you so much.
Okay, thank you, sir. Thank you, sir, for your valuable speech. And now we are going to our next part for this webinar today. So this is Ubaid Rahman from SuperMap Asia and Oceania Center. I'm here from the SuperMap technical team as a technical support engineer. So welcome again, everyone, in today's SuperMap mini classroom webinar volume 18, GIS-based network analysis for the root network in SuperMap iDesktop. We from SuperMap and also collaboration with CIRS and North-South University presenting today's webinar to you. Okay. So first of all, I would like to introduce you the SuperMap company, and SuperMap founded in 1997 in Beijing, founded by Dr. Eshan Zhang, and it has 23 more than 24 years actually for GIS software, working as a GIS company, software company, and it has more than 4,000 employees and 1,000 partners in 30 plus countries in the world, and also it has 38 branches, offices, and subsidiaries all over the world. Here you can see that SuperMap has 5 main key technologies like big data GIS, AI or artificial intelligence GIS, 3D or 3D GIS, distributed GIS, and cross-platform GIS. Big data GIS actually for performing the analysis like big data, like a huge amount of data set from all over the world, like the analysis of traffic of the airports, analysis of some footage or like industries or other sectors. AIGIS for extracting information from images or from performing the real-time analysis using the artificial intelligence. 3D GIS to demonstrate the BIM datasets along with GIS, and also the other datasets like building construction or like other traffic simulation, etc. And the distributed GIS is for like that a single platform using different types of devices and different types of OS and also other platforms. And the cross platforms is like that is a single software using different types of operating systems like Linux, Unix, or Windows. You can use both of them in a single using a single software or a single platform. So for today's GIS-based network analysis for the root network in SuperMap iDesktop, I'm again welcoming you as a technical engineer from SuperMap Software Company Limited, SuperMap Asia and Oceania Department. Okay, so first of all, what is actually the network analysis? The network analysis is a process to solve the practical problem by analysis in network actually. So is in using the like models such as path analysis, service area analysis, process facility analysis, and some others like location allocation analysis, etc. So it is basically a process to solve any network related problem related to root network, related to service area network, etc. And who can actually use or utilize this solution? So first of all of the department from the different types of sectors can use such network analysis solution like electronic navigation, telecommunication, transportation, tourism, and many more. And as long as they have network data need to manage and analyze especially, they can use such type of network analysis solution using SuperMap iDesktop. Okay. So here you can see like solving some practical problem using network analysis in SuperMap iDesktop, like what's the shortest route from point A to point B, or like vice versa. In the tourist attraction, how to choose route which can pass the most point of interest at the time. How big is the coverage area of the customers of a newly opened SuperMap, and how to determine its passage volume. Like others, like how to dispatch the recent fire engines for the rescue in the event of a fire, or like how can a distributor deliver all his delivery tasks at the shortest time. Okay, so for now we are going to our live demonstration for today, transportation network analysis in using SuperMap iDesktop. Okay, so we will use SuperMap iDesktop.net 10.1.1, and you can download the software from directly from the SuperMap website. Like I already opened SuperMap website here. You can see like supermap.com/es, or you can just Google it. Okay, just Google it like SuperMap, and then you will find the link to download directly from here, or you can go to the website from here. This is actually the SuperMap website, and here you see okay, so here you will find like support documents here from the download and online hub. You will get one option, and if I click here, you will get all of these products or platforms of SuperMap. And for today's, we will use only like we will only use this SuperMap iDesktop. Okay, so here you can see SuperMap iDesktop. Yeah, here you will find like Windows 64-bit version, Windows 64-bit green version, and also you will find the SuperMap iDesktop X from here. But today we will use this SuperMap. You can use this SuperMap iDesktop X. Sorry, we will use this one, SuperMap iDesktop. I already have downloaded and also installed in my PC. So from here, you can download the software directly. Okay. So this is actually the interface of SuperMap iDesktop. Here you can see. Here, this is the interface for SuperMap iDesktop. And this is actually the menu bar and ribbon. Here you will find like start, data, 3D data analysis, spatial analysis, traffic analysis, geoprocessing model or view, and also have the online support window from here, and some other panels, and also here. So we will go to the detailed demonstration of this software. Now I'm going back to the presentation. So for today's workflow, we will follow such workflow like we will create a network model dataset. We will we'll perform optimal path analysis. We will perform traveling salesman problem or TSP analysis. We will perform closest facility analysis. And after that, we will perform service area analysis. We'll perform location allocation analysis in today's SMC webinar. Okay, so we will perform all of this analysis and today. So first of all, we can see here that the network model in SuperMap. Here you can see that SuperMap have both 2D network and 3D network, and also it has two different set of network model, like transportation network model, which is with no direction, and also facility network model, which is with the directions actually. So here the network model, actually what is network in such analysis and in such model? The network is a model which is composed of a group of interrelated arcs, nodes, and their attributes actually. So in this image, you can see that there have some like nodes, some arc, and also there have some barrier points actually. So actually the barrier point and barrier edge is like that in a real world situation, there may be some barrier in our root network, like where there may be the construction is ongoing in a road, or the some other distraction is has done in a road, or like other accidents or any types of obstacles in any roads, or any types of barrier in any roads, showing like barrier points and barrier edge in any nodes. So these all the are the composition of a group of interrelated arcs, nodes, and their attributes in a network model. And the basic concepts involved in the network nodes are actually the nodes, the arc, network resistance, center point, obstacle edges, obstacle points, turntable, etc. So the network model, and this is actually how to create a network model. So we actually there have two options. One is like using point dataset, which is optional actually, and we need the line dataset. Line dataset means actually this is the root network dataset in your study area or in your analysis area, or your study location, or your ROI, which means the region of interest. And the preparation of prepare the field information of the network dataset is to ensure that the line data used to build the network contains a field that denotes the network resistance actually. So if I go to our software, and we already have shared the dataset, I will share all of the dataset with you. So for today's demonstration, I have selected like Dhaka city of Bangladesh. So here I selected the city boundary shapefile. Actually, it's not required to create such network. It's only for the demo, showing you the city boundary. And I have selected the hospital of Dhaka city and the road network of Dhaka city here. Okay, so here I selected three different types of shapefile, which is actually, this is the polygon shapefile actually. This hospital is like point shapefile, which is the location of hospital, and the root network, which is the line shapefile. Okay, so we'll go to our software here for now, and here you will get the start tab after installing. And I'm just closing this one. Okay, so from now, here we need to create our data set first, data source actually. So here you can see we have this untitled workspace, and under this workspace we have this data source, maps, layout, scene, diagram, model, and also some resources. So we first need to create a data source to import our data set. So I'm showing you, I already have created a data source. I am opening this file data source actually, then I will show you how to create such data source. Okay, so this is our data source, Dhaka city. Okay, so here you can see I already have created our data source, Dhaka city, and imported like city boundary, hospital, root network dataset. And I also created a new dataset like stop point to analyze the optimal path analysis. And I already created a network dataset. So I will show you how to do this. Okay, so first of all, what we need to do, okay, we need to just right click over here, and we need to select like new file data source, this one. Okay, it will create a new data source where we can import all of our data set. We can import all of our like vector data set, tabular data set, raster data set, and so on. And also we can create a new data set under new data set from here under our new file data source. So there have a plan, lots of options you can perform here. Okay, so I'm just right clicking over here and selecting new file data source. Okay, so for today I'm just keeping it name as like SMC 18 data source. Okay, saving this one. Okay, here you can see we got our data source here, and as you can see, this is our previous data source like city boundary, hospital, stop point, and I can import such dataset again in our data source. So how to import data or dataset in our data source? Like, you just need to right click over here, and here you can see that we have this option like import dataset. So we can import all of our dataset from our folder, from our specified path. So just right clicking over here, select import dataset. Okay, the input data window will appear here, and here we have the option like add file data. So it will add all of your dataset from your folder. Okay, so from here we will only select these three shapefile like .shp file and select open. Okay, it opened all of your three shapefile in this input data window, and just select this input. And also there have option, you can just here you can see hospital_0. You can rename this one by just from in this box, and also rename you can rename like Dhaka city. I can just change the name like Dhaka city boundary. Okay, here you need to understand one thing, that we can set any space here. We only use like underscore instead of space. Okay, and this is our route. Okay, city boundary, hospital, and route. Okay, then just click import. Okay, so here you can see our new data source like this one. We have imported Dhaka city boundary, hospital, and route, and also how to create such types of shape. Like if I open this one here, here you can see we have like such point file here. If I just open like road here, and I change the called layer style of this road or point, I change the color like red. Okay, these are the points of stop point, and how to create such point in our dataset. Let's just only you need to right click over here and select like new dataset from here, this one. And if you select this one, here you will get a new dataset window, and you need to specify the data type from here. There have a plenty of data type, and you need to just rename this one. Okay, and you also can set the coordinate system from here, and you can change the coordinate system from more from this window. So for now, I'm not going to this one. SuperMap iDesktop has more than 1,000 predefined coordinate system here. You can use in your own for your own region or own dataset, or you can create any other new coordinate system. Okay, so here you can just select the file, or I'm just selecting keeping all the things like as it is, and just selecting create. And here you can see like new point, or you can just rename from here like stop point. And you can just drag it over here, and also enable the editing from here, this one. Whenever you enable editing, and then you can just select this point, and you can create points for this shapefile of here. So I'm not doing such things for now. I'm just disabling the and deleting such shapefile or file. And also I don't need this data source, so I'm just closing this data source. Okay, and here I already have created one network dataset. So I will show you how to create this network dataset. I'm just opening this network dataset for now. So I'm right clicking over here and add to new map. So here you can see this is Dhaka city, and the Dhaka city root network are available here, and these are the nodes for Dhaka City node network. Okay, so for now, I'm just deleting this dataset also. I will show you how to create such dataset. Okay, so for now, we have such data source and also this dataset. We have this city boundary. If I open this in a new map, this is our Dhaka City boundary, and this is our Dhaka City boundary. This is the hospital location of Dhaka City. If I just change the what's called symbology to hospital from here, and then this is our root network for Dhaka City. And if I just change the root network for like swatches to theme swatches like this color, okay, now here you can see the Dhaka City root network, and also this is our stop point which we created later. And if I change like stop point, okay, these are the stop points. Okay, so for now I'm just going to my presentation and how to build or how to create a network model. So we need to prepare the dataset to build the network model for like point data. Point data is actually the optional dataset, and we need the line dataset. And also we need to prepare the field information of network dataset to ensure that the line data is used to build the network contains a field that denotes the network resistance. Okay, so I'm again going to my iDesktop, and I'm closing this map. Actually, I don't need this one. Okay, so to build the network dataset, first of all, we need to check our topological correction or topological validity of our root network. So to do this, SuperMap has the powerful tool to check the topology and correct them automatically in SuperMap iDesktop. So you can use this very much user friendly using. Okay, so to do this, I'm going to in our data. Here you will find that option called topology, and from this one you can check such topology like this one, line checker. So it will check all of your line, all of your error in the line, and it will correct all of the topological error if there are any error in your line dataset or your root network dataset. Okay, so I'm selecting this line checker. Here you can see that we have this tool have all of these topological handling option like intersect arc, clean overshoot, clean shadow, merge adjacent end, duplicate lines, clean undershoot, redundant vertices, etc. So here is our data source and also the dataset root network. So I just need to click OK to check all of this error. So here you can see that our pop-up window will appear that the dataset are you opening still open, you must close first. So it will automatically close your dataset and will process this processing. Okay, so I'm selecting yes, and it will check all the data in your root network. So here, as you have seen that the Dhaka City have a lot of routes to check, and it will check very much quickly, and it will show you the result very efficiently after checking. Okay, so it only depends on your dataset, size of your dataset. As Dhaka City has too many roads, there will be some error, and it will correct all of the error automatically. So you don't need to have correct all of the error in manually by yourself. So here you will get a message that will show that the process topology for line dataset root at root. Actually, this one is the dataset, and this one is actually the what called. Okay, it will show you the message actually that it's run successfully. So for now, we can create our or build our network dataset using this route as our topological correction processing have done. Okay, so we need to go to this traffic analysis, and we have this network by topology. Okay, so for here you can see that we will stack or build or create a 2D network using this root network dataset. So I'm just selecting this structured 2D network. So here you can see that we have two options here, like we have this dataset here, root network dataset in our data source, and we have this result setting, like we can select the output data source from here. If we create another data source to create all of to save all of our output, and we can rename the dataset from here, like Dhaka city underscore network, you can see. And also we have this to split option here. So there actually the split by line or split by points is the default option, split line by points. And if you wish to split the lines at the intersection point or intersection, you can select this split line at intersection. For now, I am selecting both of them. Okay, and it will create a dataset like Dhaka city network, and selecting OK. And it will create a network dataset using our Dhaka city root network, which already have corrected all of the topologies using the topology tool, which already automatically corrected all of the errors. Okay, so here you can see error a message showing that successful dataset network creation finished, time cost 26 seconds. Okay, so I'm just opening this dataset. Right click, you can just open, just selecting and dragging it over here. Okay, so here a prompt message showing that the dataset Dhaka city network is too large to create a special index to speed up the dataset speed. So if we select this yes button, it will speed up to process this too large dataset in your SuperMap iDesktop, which is a great power or great ability of SuperMap iDesktop. Okay, so yes. Okay, so here you can see there have a lot of routes in Dhaka city and the point datasets. So it's working like very quickly. Okay, so for now I'm going back to, and also if I see that this network dataset has two types of data for now. Here you can see we have this Dhaka city network. It is a line dataset, and the Dhaka city network node, actually this is the node of all of the routes. Here you can see all of these points nodes here, and this is the route and the node. These two datasets build our network datasets to perform all of the network analyses. And if I go to the attribute table of this data, okay, here you can see there have two types of node. Actually, this is the SM from node. F node actually denotes the SM or SuperMap from node, and this is T node, that means the to node. Actually, this is the point where there is from node. This is the distance from node, and this is true distance to node actually, or to point actually. So I'm just closing this one and going back to my presentation. Okay, so we will first start performing our analysis using optimal path analysis. Okay, so optimal path analysis actually is to find the path of the least resistance between 2 points in the network. The least resistance has different meanings, like such as those based on a single factor, like shortest time or lowest cost, or the best traffic condition, or the minimum toll station, etc. So here in this image, here you can see that from stop 1 to stop 2, there have much more nodes or much more what called turning points in this green line. Actually, it has 1, 2, 3, and 4, but from step 1 to step 2, this red line showing that it has only one turn, like one, yes, this one, actually only this point. So the result is showing that it is much suitable to use this red one than this, instead of using this green road, actually. So this is the main theme of optimal path analysis. It will create the least resistance route for the shortest time, the lowest cost, and the best traffic condition, and also the minimum toll stations. And we need to set like the stations. From here we can select the stations manually, or you can import your station like our stop point dataset in our environment setting, in our parameter setting, actually. And there have like other environment setting where we can select like this environment, like network dataset, forward weight field, or backward weight field, node id field, edge id field. We can select all of the things. We can enable the traffic rules, we can enable the turntable, etc. And also we have this result setting, also the tracing analysis setting. So for now, I'm going to my SuperMap iDesktop, and using this traffic analysis, and here you can see that all of these analysis are available, and this is our optimal path analysis, actually. And it's showing that it passed a series of steps which will given the order. Actually, it will follow an order and get the path with the lowest cost. Okay, so I'm showing you how to do this, and I'm selecting the optimal path. Here you can see we have these two tab here. One is like instance management, from where we can select the stations or barrier node, and also the result will be shown in here. And we have this environment setting here, and we can select like this field from here. We can enable this traffic rules from here. We can select the rules, okay, from here, and also we can enable the turntable from here. Okay, I'm not doing such things for now. I recommend you to perform such things. And also we have this style setting in our environment, from where we can change all of the styles from here. And we have this traffic rule setting. If we enable this traffic rules, we can select this turntable. Also we can select this weight setting. Here you can set the weight, and this is actually for the tracing analysis, network modeling, and also building direction for 3D network. And there have the analysis area setting. We can select the analysis area, or we can select the extent or bounds of the analysis area. And here you can see like checking the loops, if we use the loops, and we can create network model files from here. Okay, so I'm not doing such things for now. And we have this stop point. We will use this stop point for such station. And also you can add station manually from here. So I'm showing you how to do both of the things. First of all, I'm just importing this stop point as a station. So right click over here and select import, and here we'll use the stop point here. This is our Dhaka city dataset, this is our stop point dataset. Okay, so if I click OK, so here you can see we have such 9 stop point here, like station 1, station 2, and whenever you select any of the station, it will highlight in the map. Okay, this is the station 6, and this is highlighted in station 6. So for now, if I actually, it will follow a order. Actually, it will follow a series of stops which will be given order and get the path with the lowest cost. So if I run this analysis from here, yes, so here you can see that the result showing here, that result showing like it is showing that it created a path from station 1 to station 2. Then it it from station 2 it goes to station 3, and from station 3 it goes to station 4, then station 5, then it returns to station 6, then return to station 7, and then again station 8 and 9. So it actually follows an order that it will go from station 1 to station 2, then station 3, then station 4, then it will follow the whole order for all of this station. Okay, so here you can see all of the stations, and the path goes to station 1 to station 2, not from station 1 to station 8 or station 1 to station 6, and it's showing that it is following an order. Okay, this is actually the optimal path analysis. And if I just go to our next analysis, this is actually the traveling salesman problem, or TSP analysis. So what's the main difference between the traveling salesman problem analysis and also between and the optimal path analysis? Actually, the result you have seen that optimal path analysis goes from using our ordered path. Actually, it goes from station or step 1 to step 2, and then step 3, then step 4. But for the traveling salesman problem analysis, or TSP analysis, the result will not follow any order. Actually, this will not follow any station order or any step order here. So the traveling salesman problem analysis is unordered path analysis. It can decide the order to visit the nodes, and its target is to get the minimum or to close to minimum sum of the travel route impedance. Okay, so if I go to our SuperMap iDesktop here, and if I enable, we can also I will show you how to create. Okay, I'm deleting all of the things. I'm showing you another things for now here. Okay, this is our optimal path analysis, and I will show you how to not to import the station or stop point. And you can also create you can create the station by just using your mouse, add by mouse, like here, 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 and then run the analysis, and here we'll get the result. Okay, instantly. So I'm deleting such things, and also you can export the result to your existing data source. Okay, so for now, this is actually the TSP analysis, and I'm just taking a screenshot of this. Okay, so I'm just showing you how to do the TSP analysis, removing all of the things, or just select the find TSP path from here. Okay, so this is actually the same thing, but it will give you the unordered result for traveling salesman problem analysis. Okay, so for now, I'm also importing our stop point dataset here. Import. This is our stop point dataset. Click OK. So here we'll get same total 9 station here. And if I run this analysis, here you can see that the result is totally different, that it is now not following any order. So it is going to station 1 to station 8, then station 9, station 7, then 2, then station 6, then 4, then 3, then station 5. So it actually followed the least cost route or least cost path to connect all of the stations or all of the stop point. And it is the main difference between the optimal path analysis and traveling salesman problem analysis. Okay, so this is our traveling salesman problem analysis. Okay, the third analysis, we will see how to find the closest facility analysis. Actually, it is any scenario like any given group of events point and facility points, it will find one or more least cost facility points for each event point actually. And the result shows the optimal path, the least cost, and the traveling or driving direction from event point to the facility point, or from the facility point to the event point. In the meanwhile, you can set a query threshold, which is search a scope. Once beyond the scope, it will stop to find. Actually, the main theme of this analysis is that if any event point like this, here you can see this is actually the event point, or even stop, and these all are the facility point, like this one, this one, this one, this one, this one, and this one. Okay, so these all are the facility stop, and this is our event stop. If any fire accident, if any car accident, if any destruction, if any hazard, or if any types of disaster happen, if in this event stop point, and people needs to move from this point to the nearest facility point, or nearest like rescue center, or nearest shelter center on a given time or on a given distance, then this closest facility network analysis will provide the best solution for this type of scenario. It will find the closest facility for this event. It will find the nearest facility. It will find the shortest time duration, shortest cost facility for this event. So if we go to our software, and I'm just enabling here. Here you can see that find closest facility. It will search the facility point closest to the existing point or event point. Okay, so I'm selecting this one, and here you can see we have these options for now. We have this event stop, we have this facility stop, we have barrier nodes, and also the result. So I already shown you, I have already imported the hospital point location file in our data source. Actually, this will be our facility stop, and I will create an event stop to show you how to find out the or how to get the result for the closest facility for this event stop. And we can select, we can set like some barrier nodes here, and also we will get the result. Okay, and for now we will select like facility stop. We will import this hospital point in our facility stop. So to do this, like I just need to right click over here and select this import, and this is our hospital Dhaka city. And for name, this is actually the OpenStreetMap dataset. We can download your OSM dataset from any the website of OSM. It is actually open source data. So I'm just selecting the name field as name, and okay, and I'm clicking OK. So Dhaka city have 111 hospital. It will import all of the hospital as a facility stop. Here you can see all of the hospitals are available here. Okay, and you can see the hospital names, all of the hospitals and names there. And okay, this all of the hospital actually. And if any event or even in any event point, like you need to just select this add by mouse, I will create any event in this point actually to find out 10 nearest hospital. Like I have industry here, I have an industry in this point, actually event stop, and this industry caused the fire accident. Okay, so the people needs to move the nearest hospital for their initial treatment, and I will select, I want to get 10 nearest hospital from this hospital list actually. So to do this, I will just go to the parameter setting, and here you can see that we have this option like event to facility and the facility to event. Actually, as we want to move people from this event point to the facility point, we will select this event to facility. And if you have any other like vice versa, like we also need the what called the fire service to reduce the damages of this event stop, then they need to come from their nearest location in this event stop. Then we can select this facility to event. Here the facility will be the fire service station, and the event point will be the event stop. So for now we need to move people from this fire accident location to the nearest hospital for their treatment or rescue, and then we will select this event to facility. And as we wish to or as we want to get 10 nearest hospital from these hospitals, so we will select this number of facility as 10. And then if I click OK, and the parameter setting is done, and we need to run this analysis. So to do this, just select this run button. So here you can see that we got this what called 10 different types of facility from here. Or here you can see that the 10 different hospital it's selected, like event stop to high care hospital, event stop to Dhaka General Hospital, event stop to Prime Hospital, Crescent Hospital. All of this event stop to all of this hospital, and it will select the path from here whenever you select any result in your here. And I'm creating another scenario for this, like I'm deleting this event stop from here, and I'm again like I'm process facility. I'm importing my hospital again to show you another scenario. Okay, I'm going to any other location like here. Or here. Yep. So I will create a, sorry, this is not the facility stop here. I'm deleting this one. We need to create an event stop. So I'm creating an event stop here. Okay. And we want again like 8 different facility. So we'll go to event to facility. Okay. And we'll run the analysis. So here you can see that we got this 8 different facility for our event. Okay. So I'm just taking a screenshot here. Okay. So this is actually the idea or the main theme of finding closest facility for anything. You can find the closest facility for your ATM services, for station, for your business location, for your hospital location, for your educational institution, or etc. Many more. So these analyses are too much user friendly and too much easy to perform such important things. Okay, so for now I'm going back to my presentation. So then we will see how to perform service area analysis from here. Actually, the theme or the idea of service area analysis, actually it is to conditionally find the scope of service area that the specified service stations can provide. And here you need to see, and here you need to consider 2 types of basic concept here. Actually, the service stop and the service area. So the service stop can be any location, like any hospital, or like any stationery shop, or like any ATM booth, any bank location, any market, or any types of services, recreational services, or any types of other services available. And the service area is actually, here you can see in this image, service area, the service location. This is our service stop 1 and 2, and the service area showing this location. Actually, here you need to consider one thing, that they have service radius. They have the service radius in environment or the parameter setting. And here you can see the service stop 1 has the distance for 100, service stop 2 has the distance, service distance for 100. And it's not actually like the buffer analysis. It's not creating any types of same radius. It's not creating any types of circular areas for this service location. It's just only creating the distance for based on the road and the nodes of the road. So for the service area like this one, if I assign the service radius as 100, it will be the service areas for the 100, like from this service system point to this node, to this node, and to this node, and this one. They will create the distance for 100, distance of 100 from their service stop to service stop to the nodes of the roads. Okay, so if I go to our iDesktop, and here you can see we have the service area analysis, and if I select this one, there will be like service stop. Okay, so here I consider the hospital location. From here to I will consider the hospital location as service stop, and just I need to import the hospital location in service stop. Import Dhaka City, and I will select the hospital. I will select the name field as name, and here I will, as there have too much hospital like 111 hospital, I will what called query some hospital from here. And here you can see that we have this SQL expression query from here, and we will just select like SMID is less than 20. That means whenever any hospital have their SMID field value as less than 20, they will select and they will import as service stop. Okay, selecting OK and clicking OK. So here you can see we added total 20 service stop point for this 20 hospital, and this 20 hospital have the what called SMID less than 20, as we use the SQL query here. So we will select the parameter setting from here, and here you can see the service radius available here. So if we select like randomly the service radius for different types of hospital from here, as if we know the capacity of this hospital to provide services, then you can select the parameter from here. So I'm just selecting manually like 300 or 500 or like 600, 200. Okay, so I imported manually the service radius here and saving this as okay. And if I run this analysis, it will show you according to your parameter setting, the service radius parameter. These values will select or create the service areas, like Apollo Hospital have service radius as 300. And if I go to the Apollo Hospital from here, this one, it created the distance from this service stop to these nodes of the routes as the distance of 300. And if I go to any other areas like this one, here you can see we have this 3 different hospital here, like City Hospital, Bangladesh Eye Hospital, Bangladesh Medical College Hospital. 3 different hospital are available here. And if I select this City Hospital, and it will just select all, it will show you highlighting the radius for the City Hospital. This is not actually the radius, this is actually the service area of City Hospital based on your parameter. And if I select the Bangladesh Eye Hospital, okay, it will show you the common area or the radius for the areas for the services of Bangladesh Eye Hospital. And if we select like Bangladesh Medical College Hospital, this one, so then it will also it will highlight the radius for these 3 different of service areas. So this is the overlapping area actually for these 3 types of for these 3 different hospital. This is actually the service stop. And here also you can see the service stop for these 3 different hospital or service areas actually. So this is the main theme for this service area analysis. And if you can select, like if I just select this result from here, from this result section, like City Hospital, it will highlight the service area for City Hospital. If I select the Bangladesh Eye Hospital, this one will highlight the Bangladesh Eye Hospital service area. And if I select the like Bangladesh Medical College Hospital, this will highlight the Bangladesh Medical College Hospital service area from this result. And you can also what called export or save as dataset all of this result, and you can use this dataset in for your further analysis or your further uses in your data source. Okay, so I'm not saving such things for now. I'm just saving taking a screenshot for your further yeah. Okay, yeah. So this is the main theme or main idea for the service area analysis. I'm going back to my presentation. And in our last analysis for today, we will perform location allocation analysis. Okay, actually the location allocation analysis is the prerequisite for the success of commercial and non-commercial organization actually. And location allocation is to select the optimal location for one or more service providers in a certain region, so that the facilities can be one of the most cost-effective ways to provide services and merchandises. Location allocation is more than just how to locate, which also needs to allocate the demands of the demanding points to the appropriate facility services area. And there we have 2 different types of what called we need to clear about 2 different types of ideas, like our center point location map and the optimal location allocation analysis, as it will provide us the best coverage of the locations. Then we can provide the center point location in our map, or we can provide the center point or location point of our location. Then we can set the parameter for the coverages and how many coverage we want to get from this analysis. We can set the parameter. And for this scenario, I will create total 15 of hospitals in a certain area. Out of 15 hospitals, I want to get like 7 coverages, best 7 coverages from this 15 hospital using this location allocation analysis. Okay, so I'm going to my iDesktop again, and I'm selecting this location allocation analysis from here. And we need to select the center point. So if you have the center point created before, you can import them. or you need to add the center point by clicking add by mouse. Okay, so I will create center point for now for here, like 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So I already created 15 center point here. Here you can see all of the center points. These all of the 15 center points here, and we want total 7 coverage area from this 15 center point. So here the center count will be the 7. Okay, so now I'm selecting okay, and if I run this analysis, so here you can see this will provide us total 7 coverage area for this 15 center point, total 7 best coverage area for this 15 center point. And also you can save the result. You can save the result as dataset for this 15 center point dataset. Okay. Okay, so this total 5 different types of network analysis for today, and you can download all of this today's today's material, like slides, presentation, dataset, and also the software link by scanning this QR code, or you can use this link to download. And also you need to submit your result to get your certificate. Like you need to you can scan this QR code, or you can use this link to submit your result by this due date. And how to submit your result, I am showing you how to submit. Like you have to create all of this analysis by yourself and take a screenshot like this, and you need to you can just select like analysis 1, or this is the optimal path analysis, and then this is the called the TSP analysis. This is the closest facility analysis, CF facility analysis, and this is the service area analysis, and this is the called location allocation analysis. So you can name this analysis, and your name from in here, your name, your email, and organization. Here you can input all of the things here, and you need to save your file, like result, and then using this link okay, then you can submit your result by adding your file, like you're importing your name, your email address here, like name as X, email address like something like X or abc at gmail.com, for example, and adding your file here, like adding your result file here, this one, uploading the result file, and then you can submit. Okay, then this is actually your official name and official email address and the result file, and then you will get your certificate for today's SMC 18 or today's our SMC for root network analysis for the root network, GIS-based root network analysis for the root network in SuperMap iDesktop. So thank you everyone for today's participation. And if you have any question regarding anything, you can ask me in the Q&A section. Okay. So thank you everyone for joining today.
Thank you, Mr. Ubaidur. Ms. Jain, do you have anything to say?
To conclude, I just want to say that that was a very successful session. I hope that you guys have learned a lot from this session today. We will be arranging some more sessions in the future, of course, in eclectic topics and solutions, because SuperMap provides a variety of solutions, as you have seen from our past webinars and workshops. So we will be arranging some other webinars and workshops every month. So we are inviting you guys in advance for that. And thank you so much, Dr. Muhammad Sirajul Islam, for being present here today, because your guidance and your speech has given us a lot of thoughts, and also we can gain a lot of knowledge from your insight as well. Thank you so much for being present here today. So I'm requesting you to say the last words, as you have been present from the beginning and you are our honorable guest. So I'll be requesting you to give us some insight of you, and also how you think about today's session and how Ubaidur has performed so far.
Yeah, thank you so much, the SuperMap engineer, Mr. Ubaidur Rahman, who has offered a very nice, technically sound presentation. But obviously, this 1.5 hour is not enough. But surely you can contact with them, and you can have a look at those promotional videos at their website as well. And if you continue to learn, search, I think if you have interest on this particular issue, at one stage you can surely master on this particular topic. And there will be a few more certificate courses in the upcoming days, especially the next one with CIRS. Obviously, SuperMap has MOU with other institute, but I, as director of CIRS, next training program I am proposing, or I proposed already to the SuperMap authority for stream networking, drainage networking, and water resources system identification, flood, drainage congestion, and those issues, how SuperMap software can help. And I hope within 1 month, we'll arrange another seminar or training program on that particular issue, the issue of identifying stream network, drainage path, water bodies, flood, drought, and these things. I mean, water related issues that can be solved by SuperMap. Thank you so much. I think till then, bye, and thank you once again for your kind presence.
Thank you so much, and thank you everyone for being present here today. So your certificates will be sent through the emails, and also other materials such as the recordings and also the PDF files. Everything will be sent through the registered email. So we hope to see your kind participation while you submit your homeworks and stuffs. Yeah. Have a great day, everyone.